conditionals, but we also talked about the contrapositive. What does the contrapositive do again? It negates them and exchanges the antecedent and consequent, right? So it has the antecedent and consequent both exchanged and negated. We also talked about the truth table. Now, if I'm doing a truth table is a table that shows all possible truth outcomes. So if I want to do all possible truth outcomes, what do I have to do for this first column for P? I have to do true, true, false, false. And what about for the second column? True, false, true, false. And if I'm doing P conditional Q, a conditional is a statement that's only false if the
antecedent is true and the consequent is false.
So which row is my mom lying to me?
Second one.
On the second row, my mom is lying to me. The antecedent is true and the consequent is false. I cleaned my room. I didn't get to go to the mall. Everything else is true. But if I want to do a truth table for this, I need to know something about negation Q. So tell me what a negation is. Okay, Kevin.
A negation is a statement that has the opposite truth value of a given statement.
Exactly. So if I want the opposite of Q, that means I want the opposite of true, false, true, false. So what do I put?
False, true,
False, true, false, true. And I also need negation P. So what would I put for negation P?
False, false, true, true.
False, false, true, true. And now I'm ready to look at negation Q, conditional negation P. Yes, sir. Mm-hmm. So where's my mom lying to me now?
The third row.
Third row? I've got false and true again. Second row, here's where I cleaned my room. I didn't get to go to the mall. That's where my mom's lying to me.
But it's negated, so that means you didn't clean your room and then you went to the mall.
Right, but it's still a conditional. And a conditional still has to be a statement that is only false if the antecedent, the thing that comes first, negation Q, is true. And the consequent, the thing that comes second, has to be false. So I'm still looking for TF when I'm trying to put true or trying to put false.
But wouldn't it be the same thing as in P conditional Q?
Exactly, yeah. That was one of the things that we noted yesterday, that a conditional and a contrapositive have the same truth outcomes. We get true, false, true, true for both of them. Yes, sir? Yes? And so what we're going to talk about today, the only definition we have for today is this term, logically equivalent. So for our definition, logically equivalent is a relationship that is only valid if two statements have identical truth outcomes. Logically equivalent is a relationship that is only valid if two statements have identical truth outcomes. Yes, sir.
So on P and then Q, it's only logically equivalent on the first and fourth row.
It's not that it's logically equivalent on a row. I want to look at it from a column standpoint. This column for P conditional Q is true, false, true, true. And this column here for negation Q conditional negation P is also true, false, true, true. So these two statements have an identical truth outcome. They're exactly the same from top to bottom. And so what I would do is I would say that P conditional Q is logically equivalent. And the symbol for logically equivalent is this triple equal sign, this three horizontal lines, is logically equivalent to negation Q conditional negation P. Now, if you've seen something like this before, you've probably seen something like where if I were to write 3 plus 2 is equal to 7 minus 2. How I have two expressions, they're not exactly the same, but they're equal to the same value. What's 3 plus 2?
5.
5. And what's 7 minus 2? 5. So I have two expressions that have the same value, even if they don't look exactly the same. I've got two logical expressions, P conditional Q and negation Q conditional negation P. They don't look exactly the same, but they're true at the same times and they're false at the same time. So we say that they are logically equivalent. Equivalent like equals. And there is a name for this relationship. This relationship is called the contrapositive relationship. And by the way, this is going to be problem number 6 on tomorrow's quiz. On tomorrow's quiz, I'm going to say contrapositive, and you're going to fill in the blank with these symbols. I'm going to write contrapositive, and then I'm going to have a blank, and you're going to fill in the blank with those symbols. And by the way, all the things that we're going to be talking about today, all the logically equivalent statements can be found on page 11 of your textbook. So I'm telling you that there's going to be 6 of them. The opposite of 3 is negative 3. What's the opposite of negative 3?
3.
Positive 3, right? So how did you figure that out? How did you know that the opposite of a negative number would give you a positive number?
Because you just add or subtract the negative sign.
Exactly. You need to add or subtract it. A negative times a negative is a...
Negative.
Oh, no, positive.
No, negative times a negative is a positive. And so that's the idea here. The idea is that if I want the opposite of a negative expression, I want a positive expression. What double negation says is that if I want to do the opposite of negation P, I should end up with my original statement. I should end up with P. Now, does that make sense from a sentence standpoint? What does a negation do to a sentence?
Opposites the truth.
But what word does it put in? Not. Or what word does it take out?
Not.
Now, if I'm doing double duty, if I'm doing double negation, I'm putting it in and then immediately taking it out. So this double negation kind of means that the negatives cancel each other out. That's how we would say it in our math class. The opposite of a negative 3 would be a positive 3. Or a negative times a negative would give us a positive. That's how we would say this in our math class. In logic, we're saying that the opposite of negation P is just plain old P. Now, trick question. How many letters do you see in this relationship?
1.
1. What is it?
P.
P. P is a statement. A statement is a sentence that is either true or false. That means P is either true or false. I don't have to do 4 rows because there's only one statement. A statement is a sentence that's either true or false. And what we've also talked about is whenever I see parentheses, I should try and take care of parentheses first. Do I have parentheses here?
Yes.
Yeah, I have parentheses, negation P. And a negation is a statement that has the opposite truth value of a given statement. So what's the opposite of TF? False true, exactly. Now what am I doing with these parentheses? What's hanging out in front of this parentheses? Another negation. So I have the opposite of negation P. So what's the opposite of false true?
True, false.
True, false.
So
Yeah.
it's the same as
So we went full circle.
We went full circle. We ended up with an identical truth outcome. Both columns are exactly the same. And so we would say, yes,
logically equivalent.
they are logically equivalent. The way that we prove that two statements are logically equivalent is we make a truth table.
7.
That's what number 7 is going to be, where you're going to have two statements and you're going to have to use a truth table to prove that they are logically equivalent.
On some of them, are you not going to have to do the truth table?
Well, you're only going to have to do one truth table on the quiz. The other 6 questions, I'm going to give you a word like double negation, and you're going to have to fill in the blank with this logically equivalent relationship. By the way, this is number 4 on tomorrow's quiz.
What number is logically equivalent on the test?
I'm not going to ask the definition of logically equivalent on tomorrow's quiz. On tomorrow's quiz, I'm going to give you 6 logically equivalent relationships, and you're going to write the symbols for me. And I've already given you 2 of the 6. I'm going to give you the other 4 in just a moment.
Oh, yeah.
All right, the next thing I want to talk about are De Morgan's laws.
What?
De Morgan's laws. Now, De Morgan was an English mathematician. He was working with these compound logic statements. Just like we talk about compound sentences, that's when we put two sentences together with an and or an or. What symbol represents and for us in logic? That's a conjunction, yeah. And what symbol represents or for us in logic?
A disjunction.
A disjunction. So what De Morgan's working with is he's working with ands and ors. He's working with conjunctions and disjunctions. And what De Morgan noticed were two things. One, if I take the negation of a conjunction, everything inside these parentheses, everything inside the parentheses P conjunction Q gets negated.
So it's Q negation.
Well, P still comes first, so it's negated P.
P.
Q still comes
Disjunction.
last, but it's going to be a disjunction. It gets changed. The conjunction changes to a disjunction. And so we say the opposite of a conjunction is a disjunction. The negation of a conjunction is a disjunction. This is one of De Morgan's laws. By the way, that's number 1 on tomorrow's quiz.
Okay.
Likewise, the opposite of a disjunction would be a what?
Conjunction.
A conjunction, exactly. Negation P, conjunction, negation Q. And that's number 2 on tomorrow's quiz. So what we're doing is we're saying that the negation of a conjunction gives us a disjunction. The negation of a disjunction gives us a conjunction. Now I'm going to prove one of these. The other one you've already proven on your homework. So I want to prove the first one, which means I've got two letters, P and Q. So P is true, true, false, false. Q is true, false, true, false. Something first. What do I have to do first?
P negation, P conjunction Q.
I need to do P conjunction Q. How do I know, just by looking at this, that I have to do it first?
Because it's in parentheses.
It's in parentheses. I've got P conjunction Q. And a conjunction is a statement that is only true if both two given statements are. So where does that happen? Which row are both of these statements true? The first row, and that's the only place that they're both true. Everywhere else has to be
False.
false. Now I'm supposed to do something with this parentheses. I'm supposed to do negation of P conjunction Q. So I want the opposite truth value of this given statement. I want the opposite of true, false, false, false. And we saw this on problems 10 and 11 on last night's homework.
So it's false, true, true, true.
It's going to be false, true, true, true. Now this is the left side. And I need to come up with the right side. So tell me what's on the right side that I need to work with.
Negation P.
I need a negation P, and I also need a negation Q. So tell me what to write for negation P.
False, false, true, true.
Yeah, I want the opposite truth value of this column. So I want false, false, true, true. And how about the opposite of negation Q? False, true, false, true. And I'm putting these together using a disjunction. Remember, I'm doing a disjunction because I'm doing number 1. A disjunction is a statement that is only false if two given statements are
false.
So on which row are both of these false?
First row.
Again, the first row. Everywhere else?
True.
True, true, true. And what do I notice about this column?
It's logically equivalent.
It's logically equivalent. It's an identical truth outcome.
To negation P conjunction Q.
Okay. So I'm going to write yes, they are logically equivalent. So in this logically equivalent, I'm making sure that two statements have identical truth outcomes. And the way I do that is a truth table, because a truth table is a
truth table is a table that shows all possible truth outcomes.
that shows all possible truth outcomes. If I want truth outcomes that are identical, I need to show all the truth outcomes. That's why we're using truth tables. Now I've told you number 6, number 4, number 1, and number 2, which means I have which ones left? 3 and 5 and 7. I'm going to tell you that 7 is going to be a truth table like this, where I give you a relationship to prove. And you're going to prove to me using a truth table that it's logically equivalent.
Didn't you say that number 7 was part of...
All right, so I want to talk about number 5. The opposite of a conjunction is a disjunction. The opposite of a disjunction is a conjunction. For number 5, I want to look at the opposite of a conditional, because that's the last one we haven't talked about. And I want to do the negation of a conditional. Huh? Yeah, I'm sorry. Thank you. So if I'm doing the opposite of a conditional, this is a method called denying the consequent. Now I'm calling it denying the consequent. Do y'all remember what a consequent is? What's a consequent?
The second part.
A consequent is a statement that occurs last in a conditional.
Has to come last. What comes last? P or Q?
Q.
Q. And if I'm denying the consequent, that means that I'm denying Q. That means I don't want Q. I want the opposite of Q. So it's going to be a negation Q. Now I didn't say anything about P, so P stays the same. And what happens is I end up with a conjunction. And we're going to use a truth table to prove that these two statements are logically equivalent. This is called denying the consequent. This is going to be number 5 on tomorrow's quiz. Again, how many letters do you see here? 2. What are they?
P and Q.
P and Q. So true, true, false, false. True, false, true, false. And I've got parentheses. So tell me about my parentheses. That's what's in parentheses. P conditional Q. What do I write for that column? No, you're getting it confused. What do I write for that column?
True, false, true, true.
True, false, true, true. Remember, the only time it's false is when my mom lies to me. The antecedent is true, and the consequent is false. This is the parentheses. What am I supposed to do with the parentheses?
Negate it.
Negate it. So what's the opposite of that column?
True,
False, true, false, true, false.
This is where I'm going to put the false, true, false, false. You're actually ahead of us. This is the left side. By the way, how many truths do you see there?
1.
1. So it's only true 1 out of 4 times. That's why it's a conjunction, because a conjunction is only true if both statements are true. So I only want it to be true 1 out of 4 times. Now, remind me again what P looks like. What do I put for column P?
True, true, false, false.
True, true, false, false. But tell me about negation Q.
False, true.
A conjunction. So what's the conjunction of these two columns going to be?
False, true, false, false.
False, true, false, false. Exactly. If I'm doing P conjunction negation Q, it's only true if 2 given statements are both true, and that only happens in the second row. So are they logically equivalent?
Yes.
Yes, they are logically equivalent.
But how does it do that? Like, how come it isn't just negation? Why isn't it just negation P, conditional negation Q?
The reason is because normally a conditional is true 3 times and false 1 time, because it's only false if the antecedent is true and the consequent is false. So I should have 3 trues and 1 false.
Is that one like number 7 too?
It's a little bit like number 7, yeah. So if I'm doing the negation of it, then I want to have 3 falses and 1 true. So I want something that's only true 1/4 of the time. Now, a disjunction is true 3 out of 4 times. A conditional is true 3 out of 4 times. But a conjunction is only true 1 out of 4 times. And that's why I want it to be a conjunction. And I have to figure out which conjunction would give me identical truth outcomes. And only this one does. So that's why we say that these two statements are logically equivalent. Yes, sir?
Sir, the only reason that they're logically true is the 2 columns are the same.
Exactly. The only reason that they're true is because 2 columns are identical.
So you're able to put the columns?
Yeah, we have to figure out what goes in the columns. That's why we have to come up with this columns through a truth table.
How come you get the P and then the negation Q?
Because on this right side, I've got to do a conjunction, but a conjunction of what? The first part is a P, that's kind of my antecedent part. The second part is the negation Q, that's kind of like my consequent. So I made one column for P, I made another column for negation Q, and then I put them together using a conjunction.
So then why didn't you do the other part?
Well, I had to do the other part because I need to show that the left side and the right side are the same. So I have to come up with a column that represents the left side. I have to have a column that represents the right side. And I have to see that they're both the same. Yes, sir?
They're not always going to be logically equivalent.
They're not always going to be logically equivalent, but the 6 that I'm giving you today will always be logically equivalent. Yes, sir?
What if it said, like, denying the, like, wait, no. What if it said, negation P, conditional negation P?
If it said negation P, conditional negation P?
No, negation, and then parentheses.
We have, and I'm not going to do a truth table for it because we don't have enough time. But this is going to be number 3 on tomorrow's quiz. And this is denying the antecedent.
So it would be negation.
Let me write it first. If I have a conditional, we notice that a conditional is true 3 out of 4 times, but we also remarked that a disjunction is true 3 out of 4 times. That means there's got to be some disjunction that's equal to a conditional. And the disjunction that's equal to it is if I deny the antecedent, in other words, negation P, disjunction Q. And again, I don't have time to do a 2-column proof or truth table for this because class will be ending in about 2 minutes. But if you look on page 11, you'll see a truth table for this.
Or we could look on the YouTube channel.
Or you can look on the YouTube channel, that would also have it, yes. So on tomorrow's quiz, there's going to be 6 questions. You're going to need to know double negation. You're going to need to know both De Morgan's laws. You need to know denying the antecedent, denying the consequent, and contrapositive. Yes, sir?
How much is each question worth?
Each question will be worth 10 points, and the truth table with partial credit will be worth 40 points. Yes, sir?
I didn't write down one of the things you said. You said something to double something?
Double negation. So we have double negation, denying the antecedent, denying the consequent, De Morgan's laws, and the contrapositive relationship.
Okay.
Yes, sir? You may. All right, if there are no other questions, I release you to your PA. Have a wonderful day.